This lecture is going to be a quick glimpse at outbreaks, epidemics, and pandemics. We're going to start with terminology. Diseases that are relatively common, that are what we call constantly circulating or constantly present at least some part of the planet. We don't call those epidemics, we call those endemics. And this is stuff like the common cold. There's a term outbreak, which occurs when a disease starts showing up. It's a disease that either is new or isn't very common. And it's very, very locally controlled. Outbreaks can die out or they can go on to become epidemics. Epidemic is a disease that is affecting a relatively large population, like a whole country or a couple of small countries, or in the case of the United States, which is a big country, maybe several states of the United States. A pandemic is a relatively new or dramatic increase in a disease that is multiple countries, multiple continents. Usually we refer to the whole world as having a pandemic. So how do these epidemics start? Well, they always start with an outbreak. And an outbreak can occur when a person brings a disease into an area where that disease does not normally occur. There's a disease called rubella. We don't think about rubella in the United States. It just doesn't seem to occur here very often. But if somebody who is infected with rubella visits a region of the US with low vaccination rates, you can have an outbreak. We have a vaccine, the measles, mumps, and rubella vaccine, that protect us against this particular virus. But with the antiviral movement getting larger, we're starting to see diseases like rubella and measles show up in the United States. Outbreaks can also start with what's called a spillover event. This is probably what happened with COVID. And this is a situation where a zoonotic disease spreads from animals into humans, usually for the first time. So we think COVID was a spillover. We're going to get into that a little bit later in this lecture. In China, buying live wildlife and butchering it and preparing it at home is kind of a status symbol. So it's very common among the middle class in China to do this sort of thing. HIV, we're really confident that that probably came about when somebody was hunting chimpanzees and they cut themselves while butchering the chimp. And it may have moved into humans multiple times before it was successful in causing a human disease. On rare cases, outbreaks can start with lab accidents. A researcher in a lab accidentally exposes themselves to a disease and then carries it out into the public. We don't usually have good evidence that this is what happened. but we believe them to be pretty rare. We've got pretty good records in the US about lab accidents, but not every country is as good at keeping track of that as we are. The 1977 flu pandemic is probably the largest outbreak associated with a lab accident. And it was probably started at a lab in Russia, or at the time the Soviet Union. Usually when we have these sorts of outbreaks, there are only a few people infected by an individual accident. So when we think about epidemics, there are certain conditions in society that are going to increase the risk of epidemics. Movement of people. This can be travel, immigration, fleeing war zones, fleeing poor economic situations, fleeing horrible civil rights conditions, especially if the conditions that people are leaving were hard and physically they aren't in the best shape, they're going to be more likely to be able to transmit diseases. Malnutrition is a big, big issue. I don't mean eating an unhealthy diet in America. I mean real malnutrition. Not being able to get enough calories, not being able to get enough of the various vitamins that we get from our food supply. Overcrowding. Anytime you have a very crowded condition, it's much easier to spread disease between people. And the last condition is exposure to wildlife. And I don't mean going for a hike out in the woods. I mean destroying natural areas, areas with new housing in a place that used to be wild. You're more likely to get a spillover event. Because the wild animals have to come in closer contact with people in order to survive. There's not a magical place that animals can move into when we destroy their habitats. There's really not that much wilderness left. Another way people get exposed to wildlife is the exotic pet trade. Oh, yes, everybody seems to go through phases where they want some exotic animal, be it a tiger or a monkey or shoot, now I can't think of. Anyway, whatever the exotic animal is. A lot of these animals are going to be captured from the wild, and they can be bringing diseases in. The third way that people get exposed to wildlife is the bushmeat trade. Bushmeat refers to hunting wild animals for food. It can also include fish, but we don't generally get diseases from fish. So in the US, the bushmeat trade includes deer, elk, duck, turkey. And this is one reason why most places in the US you are not allowed to sell meat that you hunted. So if you go out and hunt a deer, most places in the US you're not allowed to sell that meat. And that's because it can spread diseases. These images here on the left is the plague doctor outfit. This was designed to try and protect doctors from the plague. You'll notice this plague doctor has his entire body covered. That coat that he wears is covered with a layer of wax. He's wearing gloves, goggles, and that mask, which, while he can certainly breathe through it, it's got that long beak so he could stuff it with herbs, which at the time they thought would protect them from the plague. On the right is a training hazmat suit. This is basically what the modern day version of the plague outfit looks like. It's not comfortable. It's not pleasant to wear. And they are well over $1,000 each. This training suit, I saw it for sale. The ad that I got this from said it was $750. It's a training suit. It's not the real deal. So let's talk about our current pandemic, COVID. There's a lot of very bad information out there. If you find that your admittedly uninformed personal opinion disagrees with expert consensus on a technical topic, please consider that all the experts know something I don't is a more likely explanation than I alone solved a complex problem experts have long been studying. Or I found a secret on the internet that the experts don't know about. So misunderstanding comes about in part because the average person does not have a good understanding of science, of how it works, how much time it takes. And there tends to be, people tend to forget that scientists are people too. And scientists make mistakes, just like any other person. And so when there's a correction, a lot of people are like, oh, look, science didn't work. Not, well, we found new information and we're revising our idea of what's going on. Or, you know, I kind of screwed up the experiments and we thought we knew the answer, but somebody else tried to do the experiments and couldn't do it, and now we realize there was a mistake. Some of the misinformation is deliberate. So if you've heard about using hydroxychloroquine or ivermectin instead of getting vaccinated, both of those rumors can be tracked back to individuals who own stock in companies that make these products. They stand to make huge amounts of money by convincing people to buy those products. Hydroxychloroquine and ivermectin do nothing for COVID. And in fact, they can make you very sick or even kill you. The other thing that causes a lot of misinformation to go about is fear. Fear makes people less rational and more likely to believe in conspiracy theories, especially in an absence of real understanding. There's a lot that we still don't know about COVID, and it was even worse last year. So this lack of knowledge, this vacuum of understanding was filled with whatever piece of information somebody found on the internet or heard from your crazy uncle that you really shouldn't be listening to. If there was an easy cure, do you really think that doctors would not tell people or not know about it? You're not going to find the magic cure for something on the internet. So one of the ideas behind the origin of COVID was that it was made in a lab and deliberately released. This shows an underestimation or not recognizing the power of nature and the power of evolution. It also overestimates the ability of scientists. Creating a new virus or bacteria is hard. It's only been done a handful of times, and we really don't know what most of the genes in viruses do, or why this particular gene makes a particular virus more deadly. We just don't have that knowledge. And besides that, why create a new disease? There are plenty of options for bioterrorism that already exist. The Black Death killed 60% of people in Europe. We can treat it with antibiotics these days, but if you created an antibiotic-resistant version, smallpox, depending on the population, would kill between 30 and 50 or 70% of a population. A few years ago, about a decade ago, the Middle East respiratory virus, which is another coronavirus, that killed about 30% of people it infected. COVID has killed about 0.5% of the US population, which is huge. We're almost to the point where we've lost the same percentage of the population as we did during the 1918 flu. And we have a lot better understanding of disease transmission. We have a vaccine. We have much better medical care than they did in 1918. So it is a nasty little virus. The scientific consensus is that COVID originated in bats. So bats have a lot of diseases in this category of coronavirus. That's what the COV stands for in COVID. Coronaviruses are a little bit flexible in their host, but we don't tend to get them directly from bats. We think it goes from the bat into a secondary species, like the civet or the pangolin or the camel. So in 2002, a coronavirus outbreak occurred. It's called SARS. And that was tracked through a civet that got it from a bat. MERS in 2012, it was a bat infected a camel, which infected a person. SARS-CoV-2, we're not sure of the intermediary yet. It might very well have been a pangolin, but it definitely came originally from a bat. And so what happened was a bat or a group of bats with a coronavirus was captured for the bushmeat trade near Wuhan, China. They were taken to what's called a wet market, where live animals are kept and sold to households. And at this live market, it infected another animal. These markets have very crowded conditions. The animals are under very high stress, so they are very vulnerable to infection. When the coronavirus switched hosts, this stimulates evolution in the virus. It's going to go through a lot of change to adapt to the new host. Scientists think that the secondary animal then passed it on to a human, Again, changing host stimulates evolution so that the virus adapts to the new host. We've got a good bit of supporting evidence for this idea, but we're probably never going to find the original virus in wild bats, in part because it evolved quite a bit before it became COVID-19. And in part because nobody's going out and catching bats and looking at all of the viruses they carry. They tend to have a lot of different coronaviruses. We don't know where the original infection came from. We don't know where those original bats were captured. But we're pretty comfortable with the idea that it was a zoonotic disease originally that spilled over into the human population, evolved to become the deadly virus that it is today that's caused this huge pandemic. Okay, so that's my quick overview of epidemics. If you're really interested in them, there's a class called Epidemics, Past, Present, and Future that is synchronous but remote that will be taught in the spring semester.